Hello everyone. Welcome once again to another deep learning related tutorial on our channel Cholesterol Training by Slidescope. In this part, we will learn about car images classification using Convolutional Neural Network CNN. So the dataset that we are using here is this fantastic dataset that we can get from Kaggle. And here in the dataset, we have different type of car images. So this data set, car data set by Mr. Shitish Kumar. In this car data set, we have two folders, test and train. So in the test folder, let's say we open Swift or Tata Safari, whatever folder you will open. So you will find some image files here, right? And these image files will be used to train the model. So model will learn how a Swift looks like, right? How a Audi looks like, how a Hyundai Creta looks like. So for different type of car models, we have different type of images here. And the first thing will be to load the data in your application. So in your application or in your machine learning project. So we are using Google Colab here because Google Colab can load the data files directly from Kaggle, and all the images used in the project, everything that we see here, uh, all the credit goes to this particular user and this Kaggle. We are just doing it to explain users how to perform or how to apply CNN on such datasets. We have done one more video about image classification with CNN. So here we will create a CNN model to classify car images into 7 categories. That is Audi, Hyundai Creta, Mahindra Scorpio, Rolls-Royce, Maruti Suzuki Swift, Tata Safari, and Toyota Innova. Why should we use CNN? Image classification requires extracting meaningful features from images to identify patterns within the dataset. And CNNs are ideal for this task as they utilize a hierarchical structure that progressively builds a network, narrowing down to a fully connected layers, that is dense layer, where all neurons are interconnected to process the final output. So we have done some basic tutorials about what is CNN, how it works, its basic principle. Here is the practical implementation of CNN. So let's load the data set first. So to load data set from Kaggle, you have to import the module Kaggle Hub, and then we are naming it is J92 car image dataset path is equal to Kaggle Hub dot dataset download, and here we are writing the input here. So when you will write this and run this, it will import the data set. So it will take some time to get connected to the compute engine backend and then start downloading the files from GitHub, from Kaggle. Sorry. And here 36 MB file is downloaded. Now we will import NumPy for linear algebra, import pandas for data processing, and import OS. So you write it like this for Kaggle input, and here it will load the data. Now we have the data in our project here, in our Google Colab here. Next, we will import the necessary libraries. So from TensorFlow.keras models, we will import sequential. From TensorFlow.keras layers, we will import dense dropout, convolutional 2D, max pooling 2D, flatten. So earlier in one of our videos, we did object classification on CIFAR10 dataset for computer vision, where we used CIFAR10 dataset, import TensorFlow, where we explained the different usage. So in basic, if you'll do a Google search or just understand, TensorFlow is used to develop machine learning models and perform numerical computations. It's a library that helps data scientists and engineers streamline tasks like training your models, processing data, deploying your models, and acquiring data, serving predictions, and refining future results. Next, what is the use of TensorFlow.keras.layers? So when we use TensorFlow.keras.layers, and from that we import dense dropout, This line imports specific layers and functionalities from TensorFlow's Keras library for building a CNN. Dense means a fully connected layer where every neuron is connected to every neuron in the next layer. Used for classification and regression tasks, dropout is a regularization technique and randomly drops a fraction of neurons during training to prevent overfitting. Then we have convolutional 2D, a 2D convolutional layer that is used to apply convolutional filters to extract features from images like their edges or textures. Then we have max pooling 2D. This is a pooling layer that is used to downsample the feature maps by taking the maximum value in a specific window, reducing the dimensionality while retaining key features. And then we have flatten. It flattens the multi-dimensional features map into 1D vector to feed into the dense layers. So you will import these different layers from Keras layers, and the model that we will use is sequential model. So one by one sequentially these layers will be imported, and we will import TensorFlow as TF, matplotlib.pyplot as PLT for plotting different type of images here, and then ipython.display we will import HTML for displaying purpose. You will just understand all of this. Next we have code from tensorflow.keras.preprocessing.image import image data generator. Image size is equal to 128. Then train the data generator, image data generator. So we will use that class, rescale it to 1 point by 255, rotation range 10. So what is this code means? This code is setting up the pre-processing of augmentation for image data to train a deep learning model. Image data generator is used to apply real-time data augmentation and processing, pre-processing to image as they are loaded. Rescale. This normalizes pixel value by scaling them to the range of 0 to 1, improving model training. Then we have rotation range is equal to 10, randomly rotates images by up to 10 degrees to help the model generalize better. We have horizontal flip is equal to true, randomly flip image horizontally to increase diversity in the training data. And then we have train generator. This creates the data generator that loads images from the specified directory, the directory that we are using here, the Kaggle directory, and applies the transformation. Target size is equal to image size comma image size, that is resize all images to 1 by 128 by 128 pixel. These images are very large, you know, they may be 2 megapixel, 1 megapixel, can be those pixels. So we are resizing them to 128 by 128 pixel array, and class mode is equal to sparse. The labels are integers representing the class. Example, different car types, class mode, which is suitable for multi-class classification with sparse labels. In short, this code prepares the training images, applying normalization and augmentation, that is rotation and flipping, to help the model generalize better while also resizing the image to 128 by 128 pixels. Now we will simply copy the code from here and paste it here. You just have to remember one thing. Here we imported the data set into this variable, right? Saved the path into this variable. So here we just have to use the same path. And now you can see found 4165 images belonging to one classes. Now our next line of code is we are using count is equal to 0 for image batch that we have created. Like here, first of all, from TensorFlow Keras we have created it, and we have created train data gen and train generator. Okay, so count is equal to 0 for image batch comma label batch in train generator. Print image batch 0, and we are breaking it. First, let's see the output and then understand what is this. This code is iterating through the batches of image generated by the train generator and printing the first image in the batch. For image batch, label batch in generator, this first thing, right? This here. This loop iterates over the batches of images and their corresponding labels produced by the train generator. In each iteration, image batch contains a batch of images and label batch contains the corresponding labels for those images. So image batch will have the image and label batch will have the corresponding label, like what label is it, what car is it. And print image that batch 0. This print the first image in the current batch. This the image batch is a batch of images. It's a numpy array. So each image is indexed by the number of image, refers to the first image. The break statement stops the loop after the first batch is processed, meaning it only prints the first image. So in short, the code prints the first image in the batch from the training data generator and then it stops the iteration. So here we are just printing the first image. Okay, this is the first image. Now, obviously, this is looking quite. If I will ask you what car is this, no matter how much of a car lover you are, no one can tell this. So that's why we have imported PLT. So you take this image, image batch 0, and write PLT dot im show. In PLT dot im show, you will be able to see it's a car. Some car is here. So that's what it has done. It has shown us the first car, let's say image batch 1. So now you can see in our image batch there are different type of cars, let's say 8. So this way you will be able to see what images it is going to train the data. This looks like Swift here. Now all our class names are in train generator, the class indices dot keys. So this way you will be able to print all class names. So class names is car data set, right? Now as we use the training data set for training images generator, we are also using test data gen. So here we have test generator. So here also we have to replace the variable name. So first we will copy this variable name from here and we will just replace it with the path. So now we will have the test image generator. So from our testing batch, we can print the first image. And if this is some image, right? And if you want to see what image it is, so you can use again the same thing, plt.image batch 0. Looks like Creta. So now we have these images and now we will train our CNN model. Next, before creating a CNN model, you have to understand how to stack layers in CNN. So in convolutional model, we have ReLU, pooling, convolutional ReLU, pooling, flattening, fully connected layer. CNN is composed of three main type of layers. First is convolutional layer, pooling layer, and fully connected layer. These layers are stacked together to build the architecture of the CNN. And a typical sequence of layer in a CNN may look like this. Convolutional layer. This is the first layer used to extract feature from the input images such as edges, textures and patterns. So you just saw to a human eye this is an image, but model will see this image like this as an array. In this array there will be different type of features, right? So the convolutional layer will uh, use these features. So this layer will extract features from input image and then these features can be edges, textures, patterns, etc. And it applies convolutional operations using filters to detect these features. So in machine learning, convolutional is a mathematical operation that combines two functions to create a third function. and it is used in a convolutional neural network to process grid-like data like image, which is a grid-like data. Then we have pooling layer. This layer reduces the size of the feature map produced by the convolutional layer, which help in lowering computational cost. It works by downsampling the feature maps, typically using operations like max pooling, and operates independently on each feature map. Then we have fully connected layer. This layer consists of neurons that are fully connected to all neurons from the previous layer, and it connects the features extracted by the previous layers and help in making final predictions. It contains weights and biases that are adjusted during training. Then we have dropout. Dropout is a technique used to prevent overfitting by randomly dropping, that is setting to zero, some of the neurons during training. This forces the network to rely on different combination of neurons, making the model more robust and reducing the chance of overfitting. Then we have ReLU, the rectified linear unit function, which determine which information should be passed into the next layer in the network, and it applies a threshold where any negative value are set to zero and positive values are passed forward, adding non-linearity to the model. So in summary, stacking layers in CNN allows it to progressively extract features from the image, reduced its dimensionality, and finally make predictions based on learned features. Each layer type has a specific role, from extracting features to making final decisions, and techniques like dropout help in preventing overfitting. When you will apply this on various examples, then you will slowly keep understanding the use and purpose of each layer here. Now let's build the CNN model. SZ, as the name suggests, size of the images 1 to 8. Model is equal to sequential. A sequential model is created, which means layers will be added one after another in a linear fashion. Next line is, in model we will add convolutional 2D. Here you can see some parameters 32, 3, 3. Input shape is equal to sz, sz, which is size, comma 3. Activation is equal to ReLU, and then model dot add max pooling 2D and 2 comma 2. So let's understand convolutional 2D 32 3 by 3. This adds a 2D convolutional layer with 32 filters, each of size 3 into 3, to learn different features from the input image. The input shape sz, sz, 3 is specified that the input will be an image of size 128 by 128 with 3 color channels RGB. As you can see, every image here used is a colored image. So every color can be specified with RGB. So if you don't understand this, there is a simple website HTML color codes. Let's create a red color. So its RGB is different. Let's color green color. Its RGB is different, right? So 128 by 128 image size and 3 color. These arrays are basically representing this type of features. Then activation ReLU, the rectified linear unit activation function, is used here to introduce non-linearity, allowing the model to learn more complex patterns of these images. And max pooling 2D is equal to pool size 2 comma 2 here. This applies a max pooling operation to downsample the feature map, reducing its size by half, taking the maximum value in a 2 by 2 window. Similarly, we will add a second layer. So model.add convolutional 2D, and again we are using a second layer here. Now this again another 2D convolutional layer with 32 filters similar to previous step, but this time without specifying input shape as it's already defined. And then max pooling 2D, another pooling layer reducing the size of the feature map further. So we are sequentially reducing the size of the feature map as well. Then we use model.fatten. So let me explain this text. The flatten layer flattens the pooled feature map into a one-dimensional vector. This is necessary before passing the data into fully connected dense layers, as dense layer expect one-dimensional input rather than multi-dimensional feature map. So this way our entire data is there, and you can see your model's entire summary here. So you can see all the layers that are used, total parameters used, trainable parameters, non-trainable parameters, everything can be seen here. So first layer max pooling, second layer max pooling, and then finally flatten. Now we will simply compile the model. So model.compile, we will use optimizer Adam. Loss is equal to tf.keras losses, sparse categorical cross entropy from logis false, and metrics that we are going to use to compile is accuracy. And next step is to fit the model. So we will model fit with train generator, and validation data will be test generator, and we will create 50 different epochs 50 times. So this will take some time, and you will see for each epoch it will start training. Like, this is something that is going to take some time.